So in this video, we're going to talk about odds, and I just want to warn you, it's very common for individuals to confuse the terms probability with the odds. And so odds and probability are related, but they're not the same thing. And so I want you to pay particularly close attention to the distinction between odds versus probability. They're related, but they're not the same thing. If the outcomes of a sample space are equally likely, then the odds against an event E are the number of outcomes that are against E occurring compared to the number of outcomes in favor of E occurring. The odds in favor of an event E are the number of outcomes that are in favor of E occurring compared with the number of outcomes against E occurring. And we write these odds as, so if we're talking about odds against E, that's going to be the number of items in E's complement colon the number of outcomes in event E. So odds are a ratio of, like in this case, it's odds against, so it's the number of ways that E cannot occur compared to the number of ways E can occur. That's the odds against E. And the odds in favor of E is the number of ways that E can occur, or the number of outcomes in event E, compared to the number of outcomes in E's complement. So the number of ways E can occur compared to the number of ways E cannot occur. So odds against, odds in favor. We do also have to pay attention. Are we looking at odds against, or are we looking at odds in favor? So like a probability for event E is the number of ways E can occur compared to the total number of outcomes in the sample space. Odds in favor of E is the number of ways E can occur compared to the number of ways E cannot occur. Now, using a colon is probably the most common way of writing odds, but we can also use the word to, and we can also use fractions to express odds as well. So again, odds and probability are similar, but they're not the same thing. So take a look at example 7 here. Revisit the problem in example 3. What are the odds against the ball landing on black? What are the odds in favor of the ball landing on an odd number? So if we look back at example 3 was the roulette wheel. And so again, we want to know what are the odds against the ball landing on black. So what that would be is, the odds would be the number of ways the ball can land in a non-black slot compared to the number of ways the ball can land in a black slot. So we have to think about it. So we're doing the odds against, so this is going to be the number of ways that it's not a black slot compared to the number of ways that it is a black slot. Well, we counted earlier and we found that there were 18 black slots. Now, if there are 18 black slots and there's 38 slots altogether, that means there has to be 20 non-black slots, which would be the 18 red slots plus the 2 green slots. So there are 20 non-black slots compared to 18 black slots. So the odds are 20 to 18. Now we could reduce that. 20 and 18 can both be divided by 2. So 20 divided by 2 is 10. 18 divided by 2 is 9. So we would say the odds are 10 to 9. So again, this is the odds against the ball landing in a black slot. So the odds against the ball landing on black is 10 to 9. Question B, what are the odds in favor of the ball landing on an odd number? Well, again, we looked earlier and we found that there were 17 odd numbers. Well, if there's 17 odd numbers, so that's going to be the number of ways E can occur. So that's, now this is, in this case, this is in favor. So that's the number of favorable outcomes. And then if there's 17 odd numbered slots, then that means there has to be 21 slots that are not odd numbers. So again, if I pull this back in, you could go through and count, or you could look at our list and count. We did that earlier. There are, again, 17 odd numbered slots out of 38 slots altogether. So if there's 17 odd numbered slots, that means there has to be 21 non-odd numbered slots, meaning even numbered slots. So the odds are 17 to 21. And in this case, that doesn't reduce, so those are the odds in favor of the ball landing on an odd number slot. So again, the key here, and the reason why we're discussing this, is the word odds is often confused with probability. And odds and probability are not the same thing exactly. They're related, but they're not the same thing. So again, we can have odds against, which would be the number of non-favorable outcomes compared to the number of favorable outcomes. And there are odds in favor, which is the number of favorable compared to the number of non-favorable outcomes. Now, as I mentioned, probability and odds are very much related. So if E prime is the complement of an event E, and we've discussed complements in the past, so if E is an event, then E complement is not that event. So if E prime is the complement of an event, then the odds against E are equal to the probability of the complement over the probability of the event. And the odds in favor of the event are equal to the probability of the event divided by the probability of the complement of the event. So again, this is showing the relationship between probability and odds. We can determine the odds against by looking at the probability of the complement divided by the probability of the event, and we can find the odds in favor of the event by looking at the probability of the event divided by the probability of the complement of the event. So take a look at example 8. The probability that a basketball player makes a free throw shot is 0.76. What are the odds against the player making a free throw shot? Now we got to pay attention. The probability that a basketball player makes the free throw shot is 0.76. So the probability of makes is 0.76. Now the complement of making the free throw shot is missing. So the probability of missing is going to be 1 minus that 0.76. So that's going to be 0.24. So if there's a 76% chance that he's going to make the shot, then there's a 24% chance that he's going to miss the shot. Those have to add up to be 100% or 1 if we're using decimals. And we'll talk more about complements in the next section. Anyway, in this particular case, we are wanting to know the odds against the player making the free throw shot. So the odds against are going to be the probability of the complement divided by the probability of the event. So this is going to equal 0.24 divided by 0.76. Again, the probability of missing over the probability of making. And then we can simplify this to come up with the odds. Well, if I were to multiply the top and the bottom by 100, that would get rid of the decimals. 0.24 times 100 is 24. 0.76 times 100 is 76. And then we can reduce. So we can divide both 24 and 76 by 4. 24 divided by 4 is 6. 76 divided by 4 is 19. So the odds against making the free throw are 6 to 19. So we could write that as this fraction, 6 to 19. We could write that as a colon 6 to 19, or we could even say 6 to 19. So this is the odds against making the free throw shots, a 6 to 19 odds. Take a look at example 9. Suppose the odds against Brighter Day winning the Kentucky Derby are 19 to 6. What is the probability that Brighter Day will win the Kentucky Derby? Now again, this is the odds against. The odds against are 19 to 6. So we want to figure out what is the probability that Brighter Day will win the Kentucky Derby. So the probability of will win. Now to figure this out from the odds, we just have to think about it a little bit. So if this is the odds against right here, then that means it's 19 against to 6 for. And we want to know the probability of 4 winning. Well, we can take the number of ways that we could win, which would be 6, so to speak, divided by the total. Well, 19 plus 6 is 25, so I'm going to just add those together, and so that's 6 out of 25. Or, if we divide, that is going to be 0.24, or 24%. So the probability that Brighter Day will win the Kentucky Derby is 0.24, or 24%. Or for that matter, 6 out of 25 would be the probability. So again, odds and probability aren't the same thing, but they are related. So if there's a 19 to 6 odds that Brighter Day will not win the Kentucky Derby, then the probability that he will win the Kentucky Derby is 24%. Our last example involves something that you would see from biology, a Punnett square. A Punnett square is a diagram used to determine all possible genetic outcomes in a crossbreeding experiment. So example 10, suppose a plant with one blue gene, B, and one red gene, R, will have purple flowers, BR. If two plants with purple flowers are crossbred, what is the probability of getting a plant with blue flowers, which means they would have a BB gene, a plant with red flowers, which means RR genes, and a plant with purple flowers, which would be BR genes. So we're going to crossbreed two purple flowers. And so this square right here is called a Punnett square. We can use this to figure out this probability. So again, if we're talking about a purple flower, the purple flower has a blue gene and a red gene. So we're going to put those right here like this. And we're going to put the same here along the top, a blue gene and a red gene. So this is a purple flower, this is a purple flower. And so when they crossbreed, the outcomes that are possible in this square is that we have a blue gene and a blue gene. So this flower would have a blue-blue. Whereas in this square we have a blue and a red, so this would be a BR, a blue-red. If we're in this square we have blue and red, so this would be a BR. And in this square we have red and red, so this would be an RR. So if two of these purple flower plants are crossbred, these are the four possible outcomes: blue-blue, blue-red, blue-red, red-red. So if we crossbreed these two purple flowers, question A, we want to know what's the probability we're going to end up with a blue flower. So that's a BB. Well, there's one BB out of 4 outcomes. So that would be a 1/4 probability. Or again, if we wanted to write that as a decimal, 0.25 or 25%. So if we crossbred two purple flowers, in this scenario, there would be a 1/4 probability, or a 25% chance, that the resulting plant would have blue flowers. Question B, what's the probability we would have a plant with red flowers? Well, the same kind of deal. Red would be red-red here. So there's one red-red out of 4 possibilities, so that would be a 1/4 probability, or again 0.25 or 25%. So again, in this scenario, if we crossbreed these two purple flowers, there would be a 1/4 chance that the flowers of the resulting plant would be red. And last but not least, part C, a plant with purple flowers. So what would be the probability of getting a plant with purple flowers, which means they have BR? Well, there's a BR here and there's a BR here. So there's 2 out of 4. So that would reduce to 1/2. So there's a 1/2 probability, or that would be 0.5 or 50%. So if we crossbreed 2 of these purple flowers, there would be a 50% chance that the resulting plant would also have purple flowers. So again, this is just an example from biology using this method called a Punnett square to figure out the possible outcomes and the likelihood of those outcomes when we are crossbreeding plants. So at this point, we have completed section 13.1. You should be able to handle the 13.1 homework.